However, reflect the green graphs, and now we see rather a far difference between the blue and the green graph.
What?
You mentioned earlier that the blue graph should reflect the green graph, relatively nearly, because
No. The thing is, this green line here, that is incoming traffic for one port on the switch, and the outgoing traffic for that port is coming from all the other different ports.
Okay.
So if I want to have a blue line in that graph, I would have to analyze all the other ports and find only the traffic going to this specific port and going out over that port again. So in that case, it's not that easy to add a blue line to that graph.
Okay, thank you.
But this green and this green is, in the end, the same data, one statistically analyzed with SFlow and the other one from the counters from the interface.
Is there any specific reason why you don't use counter packages to make the traffic statistics?
Sorry, can you repeat your question?
Is there any specific reason why you don't use counter packages to make the traffic statistics? Because you have the counters in the counter packages, so you can do this sort of graph, for example.
And you mean distribute it, get a percentage or something like that, and distribute this percentage over the actual value from the counters? Is that what you mean?
No, you said you assume the packet size is always the same to make the analysis how much traffic is going over this specific interface. Yeah. So why don't you use the counter packets from SFlow to collect that data and do the sampling of IPv6 and so on with the flow packets?
You could do that as well. That's another possibility. But in the end, when I when I was looking at these graphs, they are accurate enough for our purposes. We don't really have a specific reason why not doing that, but yeah.
Do you see a future where you could do more fine-grained spatial analysis, basically see traffic counters every second and so on, because a lot of platforms don't collect the interface statistics they show via SNMP as often as they would perhaps do via SFlow.
5 minutes usually, or
5 minutes usual, or 30 seconds.
The thing is, the bottleneck is not receiving that from the switch. The bottleneck is writing it down, and you have to generate the graphs. And if you want to generate graphs for 500 members, or we have 420 or something like that right now, each second, I don't think that our hot disks will like that.
Well, the only thing you would need to do is if you do this once a second, you would keep the old counter and you would get a 1 second average, and then you just keep the peak 1 second average and present that in the 5 second graph or 5 minute graph. Then you could see a very fine-grained peak. So
just cache it somehow in the software, only add it up if it's bigger, and then.
Because it would be very interesting to see how peaky the traffic is.
That would not be a problem.
No, so that would be a very interesting development to see. Because a lot of things happen very quickly, often 20 milliseconds is a long time in these aspects.
The thing what we're actually working on right now is the first things, the member-to-member stuff and the IPv6 analysis is sort of done, and the next thing is pretty much to replace the MRTG solution we have right now with SFlow counter samples. So I'm still working on that.
For RRD tool, how many RRD databases can you update a second?
A second, I don't know exactly, but we are updating right now up to 50,000 RD databases in 7 seconds, 8 seconds, or something like that.
That works. Thanks.
But we have a fast machine. RD tool is kind of nicely integrated in Perl. That makes it a bit easier, because it's not really using the same libraries as C, as far as I know. It's a specific Perl library for RD stuff, and that's pretty cool.
Okay.
Please.
I have different question about the implementation. I have a question about the implementation of S-Flow, because I was thinking about implementing S-Flow support for another thing.
The implementation software-wise from my side or firmware on the switches?
No, I don't care about the switches. I want to implement S-Flow support in an open source project.
Okay.
Well, but there. So I want to ask you, how do you handle the patent issues from S-Flow, because the S-Flow company or organization holds a patent on S-Flow, so it's not free, the protocol, and to implement the S-Flow protocol, I think you have to join the organization and sign something and something like this. So You just don't care and
no, the
release it?
The thing is, I think the difference is if you implement a generator for this stuff or a decoder. And the RFC, it is an open standard, and the RFC is out there, so you can just implement. There are a lot of open source decoders for S-Flow available. So decoding is not the point. Actually, people from this company having the rights on that, the block images we saw in the beginning, it was kind of hard for me to understand this RFC in the beginning, so I started to making this so many bits and so many bits something. And a couple of months ago, the S-Flow people emailed me if they could put that on their website, so I don't think they're kind of writes something.
So they're willing to support the people writing the software. So
I understand your point. It's the other way around. You want to generate S-Flow data in your software, of course. I don't know if that makes a difference because I'm working on the other side, so I'm not exactly sure. But I can tell you a couple of things about all these different formats, all these different. Because there are, I haven't really said a lot about that, but you can do also different things besides only providing the whole sampled packet. And there are devices that are not capable of sampling the whole packet, and you can put it into this kind of S-Flow structure, only providing MAC addresses, IP addresses, or whatever. Okay. We can talk about that later, maybe, if you want to know something about it. Okay. So the Congress. That was the total traffic we did on our core router upstairs in level D. The only thing why I analyzed that is because the MRTG graphs we have are again looking. We had MRTG running on the upstream interfaces, but everything which was traffic inside the building, and you guys know there were a lot of filers and stuff in here, and not everybody was only doing traffic outside the building. So everything which was inside the building was not going through our MRTG graphs. That's why it's kind of interesting to see how much traffic we actually had inside the building the whole time, and not only going to the other side. Still not enough, because actually we had an upstream so that we could have done that to the outside world. Well, anyway. VLAN to VLAN, that's kind of like the MAC to MAC address thing I did at AMSIX. I implemented on the first day, sitting here somewhere in the room, VLAN to VLAN analysis, what was going on between two specific VLANs, which was also kind of, the graphs were pretty empty because mostly the stuff was going either to the one VLAN where all the servers were or to the upstream VLAN. So the graphs were not that interesting, but it was still nice to see what is actually going on. Okay, and one thing I really liked about this Congress is the IPv6 traffic, because we did quite some IPv6 traffic, and in the end, okay, let's go like that. 4.5% maximum of IPv6 traffic here. I don't know if I can relate that to all the Mac users having just IPv6 turned on all the time or whatever, but it was kind of cool, because if you see the other graph showing the whole traffic, it is pretty much the same what AMSIX is doing on IPv6 on the whole platform. So we do have some users here. Yeah, 270. Okay, that's a lot. Yeah, that's what you can do with SFlow. More questions?
Do you plan to provide application port statistics or something?
Sorry?
Analysis of the applications, like IPv4 ports or so?
No, we didn't do that. I just didn't do that because I don't know, because I know exactly. I know from AMSIX that customers don't want to see stuff like that. They just don't want to have like, oh, you're doing so much porn and whatever traffic. So I just didn't do that here as well. I'm trying to only look at stuff which is sort of not too compromising for different parties. But of course you could do that, sure.
So suppose you had a magic wand. What else would you like SFlow to be supporting?
Sorry?
So if there was like SFlow 2, the Revenge, what features would SFlow have?
Oh, I definitely miss, but it's defined in the RFC already, but it's not in the Foundry hardware we have at AMSIX, support for CPU and memory usage of the device. That's something I really miss. And that could be, for example, on the RX box we have up here, I could really need that for all the specific line card CPUs.
Could you extract it from like SNMP queries?
Yes, we can do that. So it is actually there. They only have to pack it into the structure and send it out with the SFlow packet. So I'm sure they can do that somehow. By the way, I should file this feature request for Foundry at some point.
Going back to like your first slide, you said you can only do 1 gig of NetFlow, which I strongly disagree with. So if you could perhaps say how you came to that figure?
I came to the figure from, I haven't tested it, so I don't know why I did that myself, but I've heard that from people using it and from Cisco engineers actually.
Okay, because if you do sample NetFlow with... Like
okay, sample NetFlow is a different, that might be different, because I don't want to say too much about that, because I don't know that exactly, but I know that in sampled NetFlow they still have some kind of they are looking at more than they have to, and it is less efficient than SFlow.
Okay, yeah, you can do a lot of different stuff because this is layer 3 and layer 4 information if you want to.
That's true as well. On the other hand, SFlow is also doing layer 3 stuff. SFlow has also...
And NetFlow really doesn't have much of a layer 2 either, so for your application I do agree that SFlow is a better thing.
Yep. You mentioned that you don't store the potentially privacy invading parts of SFlow. Is that common, or is that the exception? You don't store the raw SFlow data because of privacy problems.
No.
Is that common? Do other ISPs do the same?
Other ISPs don't do that at all, as far as I know.
They don't record it?
I've only seen IXPs. I've only seen Lynx so far implementing something like that. They stored everything, or they stored a lot in the beginning. That's why they had quite some issues with performance. And now Vienna Internet Exchange is also implementing an SFlow solution, but not a lot of IXPs have something like that implemented at all.
And will this change with data retention directives?
The thing is, it is sampled, so you cannot really store. I mean, even if you would store everything, you just don't have the complete picture of data going over there. And you cannot set the sampling rate to 1. I've tried that.
I'll try.
And it's crashing with 2 as well. So.
I think I'd like to find out how anonymity systems would react, or how they would be compromised by sampled data. I get the impression it would be a valid attack, but I need to get some data.
Okay, yeah.
I got a question here. What's the difference on the CPU usage on the router if you're using SFlow? Does it go up?
Damn, I didn't know that some